Hello and welcome. In this screencast, we will define three new trigonometric functions in terms of sine, cosine, and tangent. Then we will practice finding exact values of all six trigonometric functions. One of the powerful aspects of trigonometry is that the subject offers us the opportunity to view the same idea from different perspectives. So while almost every question involving trigonometry can be answered using sine, cosine, and tangent functions, sometimes it's convenient to use these three related functions that are connected to the other three possible arrangements of the ratios of sides in triangles. For any real number t, for which the cosine of t does not equal 0, we define the secant of t to equal 1 divided by the cosine of t. Notice that means the secant of t is the reciprocal of the cosine of t. Since cosine of t is adjacent over hypotenuse, the secant of t is going to equal hypotenuse over adjacent. Next, for any real number t for which the sine of t does not equal 0, we define the cosecant of t to equal 1 over the sine of t. We see that the cosecant of t is the reciprocal of the sine of t, which means the cosecant of t can be thought of as the hypotenuse divided by the opposite leg. Lastly, for any real number t for which the sine of t does not equal 0, we define the cotangent of t to equal 1 divided by the tangent of t. That means the cotangent is the reciprocal of tangent. One perspective of the tangent function is sine of t divided by cosine of t, which means one perspective of the cotangent function is the reciprocal, cosine of t divided by sine of t. And from the perspective of a right triangle, since tangent of t is opposite over adjacent, the cotangent of t is going to equal adjacent over opposite. With these three additional trigonometric functions, we now have expressions that address all six possible combinations of two sides of a right triangle in a ratio. Let's practice finding exact values for all six trig functions now. Consider a right triangle with hypotenuse of length 43 and one leg of length 15. Let alpha be the angle adjacent the side of length 15. Find the exact length of the other leg and then determine the value of each of the six trigonometric functions evaluated at alpha. So we'll start with that first bullet point. Go ahead, take a minute, draw the triangle, and try to apply what you know about the six different trigonometric functions now to identify the exact values of all six. Okay, so here's our right triangle, my generic right triangle. It's never really to scale. So 15, 43, definitely not to scale. All right. But this satisfies the general description, hypotenuse 43, and the leg adjacent to that all right, so let's check our work here. We have a hypotenuse of 43, and we have, all right, let's check our work here. So we have an angle, alpha, and the hypotenuse is 43. The adjacent leg is 15. We have a right triangle here. And we know that in order to find all six trigonometric functions, we're going to need to find this opposite side of alpha. So let's start with that first. 15 squared plus y squared equals 43 squared using the Pythagorean theorem. So when we work that out, we end up with y equaling the square root of 1,624. And so we know that the sine of alpha is going to be the opposite, which was 1,624, the square root of that, divided by the hypotenuse. And then by definition, the cosecant of alpha will be the reciprocal. The hypotenuse divided by the opposite side. Next, we could look at the cosine. The cosine of alpha will be the adjacent side, 15, divided by the hypotenuse, 43. And then the secant of alpha is defined to be the reciprocal of cosine. So we'll have the hypotenuse divided by the adjacent leg. All right, next we have the tangent of alpha, which we know is opposite. So the square root of 1,624 divided by the adjacent leg, 15. And then the cotangent of alpha is defined to be the reciprocal of tangent. So we'll have the adjacent side divided by the hypotenuse. Square root of 1,624. All right, so now we want to find the exact and approximate measures of the two non-right angles in the triangle. So remember we had angle alpha, we had 43, 15. All right, so we can find alpha by using the definition of cosine. Again, we knew the cosine of alpha was 15 over 43. And if we do the inverse of that, we'll have the arc cosine of 15 over 43 equals alpha. This would be our exact answer. And the estimate in radians for that angle alpha would be 1.214 radians. Then if we want to find that other missing angle, I'll call that beta. We know that alpha plus beta would have to equal 90 degrees, or pi over 2 radians. So beta is pi over 2 minus alpha. And we saw that alpha was the arc cosine of 15 over 43. So that would be our exact value for angle beta. And using a computational device, we would find that beta is approximately 0.356 radians.